All right. Hello, everyone. In this video, we're going to talk about scheduling algorithms. So now that we know what scheduling is, if you remember from the previous video, scheduling is basically a set of policies and mechanism that controls the order in which the task is completed. Okay, so it controls the order. Now, there are certain algorithms for scheduling as well. We have preemptive, non-preemptive, first come, first serve, shortest job first, round robin, shortest remaining time next, and priority based scheduling or event driven scheduling. So we will discuss all of these one by one. Okay. Now there's also something called preemptive and non-preemptive. Preemptive is in the case if that particular process is blocked or interrupted and it goes into the waiting or blocked mode, and it cannot get executed at that point, and another program takes its place, another process takes its place. That's when it's the preemptive scheduling. Non-preemptive means that if the process came into the ready queue, it will go into the running state and then it will get completely executed. It cannot be interrupted in between. It will get completely executed from start to finish and then finally gets terminated. Then is going to be the non-preemptive scheduling. So just to give a recap, in preemptive scheduling, an executing process can be interrupted and then moved to another state, let's say ready state. So the operating system switches to the process of a new request before completing the processing of the current request. And the preempted request is put back into the list of pending requests. Its servicing would be resumed sometime in the future when it is scheduled again. And preemptive scheduling is more useful in high priority process which requires immediate response. For example, round robin scheduling or SRT, which we will discuss in some time. So in this case, like I said, the process can be interrupted because of probably another process which has a higher priority, or because of time quantum, right? In those scenarios, the process will be interrupted and it goes to the ready queue so that other processes can be executed. And this is the preemptive scheduling. So in non-preemptive scheduling, once the CPU has been assigned to the process, CPU cannot be taken away from the process until it goes in the waiting state or it's been terminated. A non-preemptive discipline always processes a scheduled request to its completion. Example, first come, first serve and shortest job first scheduling algorithms. And in the next video, we're going to start discussing about these algorithms. Hello and welcome everyone. In this video, we are going to talk about the first come, first serve scheduling algorithm. Now, this is a non-preemptive scheduling, which means that when the process starts executing, it goes from a ready state to the running state. It is going to finish its execution, so it will not be stopped in between. So it will not be interrupted by another process and it will not be stopped. It will go up until it finishes its execution. Now in this algorithm, the criteria is the arrival time. So the process that comes first will be served first, irrespective of its processing time. So irrespective of how much processing time takes, so let's say there are two processes P1, P2, and one has a processing time of higher than the other. So it doesn't really matter what their processing time is. It's not that just because one process has a higher processing time, it will be executed later. So the straightforward rule is that whatever comes first will be served first, which means whichever process comes into the ready queue first will be going into the running state first. Okay, so let's take an example. So in your examination, this is the problem that will be given to you, and it will say to you that, okay, these are the processes from P1 up until P5, and they have the arrival time, which means at what time unit they came into the ready state. And then this is the processing time or burst time, which means how much time each process will take to finish its execution. This could take 3 units of time, this could take 6 units of time, and so on and so forth. Now this unit of time could be anything. It could be seconds or minute. It doesn't really matter. For now, you can just consider that this is a unit of time. So this will take 3 units of time. This will take, P2 will take 6 units of time to complete its execution. Okay. Now the question will be, please calculate the completion time, average, turnaround time, and waiting time. So in order for us to calculate that, the first thing we'll do is we'll create a Gantt chart. Okay, so I'll show you how to create that. So in the Gantt chart, let's say at the time 0, which is the process that came into the queue. So you can take a look at it that at time 0, which means arrival time 0, P1 came into the ready queue. So we'll go ahead and write P1 over here, P1. Okay, then this will run for how long? So you can see that the processing time for this is 3 units of time. So this process is going to run and execute for 3 units of time. So we'll put 3 over here. So let's say this particular process ran for 3 units of time because that is the processing time of this particular process. Then at the time interval 3, are there any processes which have come into the ready queue? So let's take a look. So P1 is done, so we can go ahead and cancel that. So P1 is done. Then at the time interval 3, we have 2 processes, which is P2 and P3, because the arrival time of P2 is 2 and the arrival time of P3 is 3. So that means there are 2 processes. Now, how would we decide which one to execute first? Well, since it's a first come, first serve scheduling algorithm, whichever process came first will be executed first. So since P2 came first, the arrival time was 2 units, but P3 came later because the arrival time is 3 units. That's why P2 will be executed first. So we'll go ahead and execute P2. Okay, for how long? So take a look. The processing time of P2 is actually 6 unit of time, right? So 3 plus 6, that makes a total of 9. So this is going to run for the duration of 6 unit of time. That's why the next time interval becomes 9. So now P2 is also done. So we can see P1 is done, P2 is done. Now at time interval 9, are there any processes that have come into the ready queue? So let's see. Yes, there are 3 processes. One is P3, second is P4, and third is P5. Now, which one is going to be executed first? Well, whichever came first. So in our case, since P3 came first, we'll put P3 over here. Okay, and how long it's supposed to be run for? It's supposed to be run for 1 unit of time. So that's why we'll put 10 over here. So this will be for 1 unit of time. And then we can check mark this. P3 is also finished its execution. Next up comes again at 10, we have 2 processes, P4 and P5, and you guessed it right, P4 will be executed because its arrival time is shorter, so it came first. So that's why P4 will be executed. So let's put P4 over here, and it's going to be executed for 4 units of time. So 10 plus 4 is 14. Okay, and so P4 is also done. The last but not the least is P5. So we'll put P5 over here. Okay, and then how long? 4. So 14 plus 4 is 18. So it will be executed for the 4 units of time. So that's how the Gantt chart is prepared. And now we're going to calculate the completion time. So what is the completion time of P1? So take a look. P1 took 3 units of time to complete. So it got completed by 3. So we'll put 3 over here. Then P2 got finished at 9, right? 9 units of time. So I'm going to put 9 over there. Then P3 is at 10. P4 is at 14. And P5 is at 18. Okay. So that's your completion time. Similarly, then the turnaround time. So the turnaround time is equal to the completion time minus arrival time. Okay. So for how long did the process stay in the system? So that's calculated by completion time and the arrival time. Okay. So when did it come and when it got completed? So that's the difference. Okay. So 3 minus 0. So you can say 3 minus 0 becomes 3. Then 9 minus 2 is 7. 10 minus 3, 7. 14 minus 4, 10. 18 minus 5 is 13. Okay. Then we need to calculate the waiting time. And so after it arrived, how much time did it take to complete it? Okay. Sorry, this is processing time, not arrival time. So this is processing time. So turnaround time minus processing time. So 3 minus 3 is 0. 7 minus 6 is 1. 7 minus 1 is 6. 10 minus 4 is 6. And 13 minus 4 is 9. Okay, so that's your waiting time. Now, if you want to calculate the average, so what will be the average completion time? Well, we'll go ahead and make a total of this. So the total of this becomes, we calculate 18 plus 14 plus 10 plus 9 plus 3. That becomes a total of 40. So to calculate the average, you will make a total and divide by the count. So 1, 2, 3, 4, 5. So there are 5 processes. So average completion time, ACT, average completion time equals to 40 divided by 5. That makes a total of 8. So that's your average completion time. Similarly, average turnaround time. So average turnaround time, ATAT, equals, we will make a sum of this. So 13 plus 10 plus 7 plus 7 plus 3. That's a total of 31 divided by 5. That makes a total of 6.2. So 6.2 is your average turnaround time, and average completion time is this. And similarly, you can calculate the average waiting time as well. So average waiting time will become 9 plus 6 plus 6 plus 1 plus 0. That makes a total of, so this makes a total of 22. 22 divided by 5. That makes a total of 5 4s are 20. 5 4s are 20, so 4.4. So that's your average waiting time. Okay. Now it also may ask you to calculate the throughput. So let me just clear this. So throughput is actually the amount of work accomplished in the given time interval. So how is the throughput calculated? So throughput equals number of processes. So number of processes divided by maximum completion time minus minimum arrival time. So number of processes equals 5. Maximum completion time is what? 18, right? So out of all of these completion time, you can see that 18 is the largest. So that's a maximum, minus 18 minus minimum arrival time. So what is the minimum arrival time? It's 0. This one right here. Okay. So that's equals that. So 5 divided by 18. So that's your throughput. In case if you are asked to calculate this percentage, then you can just multiply that by 100 and then you can calculate it. All right. So that's your first come first serve, which says that the process that comes first in the ready queue will be served first, irrespective of what its processing time is. And when you are asked to calculate the average completion time, average turnaround time, average waiting time, then you can calculate that with the help of Gantt chart. So first you can create the Gantt chart and then you can calculate all of these values. All right. So I'll see you in the next video. Thank you very much. Bye-bye. Hello and welcome everyone. In this video, we are going to talk about the shortest job first scheduling algorithm. This is a non-preemptive scheduling algorithm, which means that if the process starts executing, then it's not going to be interrupted by any other process. It will complete its execution. Okay, so the criteria is the processing time, which means the process that comes first will be served first. And if there are two processes which are in the ready queue at the same time, then the process with the shortest processing time will execute first. Okay. So the first rule we're going to follow is that we will move the process from the ready queue to the running state in the order of which process came first. But in case if there's a tie, in case if there's a competition where two processes have arrived at the same time or they are already in the ready queue, then in that case, whichever has got the shortest processing time will execute first. Okay. So this scheduling is also known as shortest job next or shortest process next, SPN. So in the examination, if you get a question about SJN or SPN, do not worry about it. It's the same thing, it's just another name for that. Okay, so let's continue. So let's say in the examination, you will be given the question that please calculate the average turnaround time, average waiting time, completion time, and throughput for these 5 processes. And each one of them have their respective arrival time. Let's say P1 has an arrival time of 0, processing time of 3. P2 has an arrival time of 2 and processing time of 6, and so on and so forth. And we can do that. We can calculate that first by creating the Gantt chart. Okay, so let me show you how that works. So we'll go ahead and create the Gantt chart first. So at the time interval 0, okay, which are the processes that have arrived? So you can see there's only one process which has arrived, which is P1, because the rest of the processes have arrived at will arrive at different times. So at 0, we only have one process, which is P1. So we'll go ahead and put that P1, and we will execute it for its processing time duration. So it is 3 seconds or whatever that time unit is. So it's for 3 units. So we'll put 3 over here. Okay. Now, next, we'll check at the time interval 3. Are there any other processes that have arrived? Yes. P2 has arrived and P3 has arrived. So how would we decide which one to execute first? See, if you take a look, out of the two, the criteria is that shortest job first, which means whichever job or whichever process has got the lower or the shorter processing time or burst time will be executed first. So out of the P2 and P3, whom do you think has got the, who has actually got the shorter processing time? As you can see, P3 has got, because P2 has got 6, P3 has got 1, so definitely P3 wins. That's why we'll put P3 over here, and we'll execute this for the period of 1, because that is the processing time of that. So 3 plus 1 is 4. So this will be executed for the duration of 1 time unit. So it'll go up until 4. So P3 is done. P1 is done. Now at time interval 4, which are the processes that have arrived? So you can see that at time interval 4, P2 has already arrived because it arrived at 2, and P4 has also arrived. So both the processes have arrived, but which one has got the shortest burst time or processing time? So you can see P4 has got the shorter because P2 has got 6, P4 has got 4. So definitely it's P4 that will win. So P4 will go here. So it'll start executing. How long will it execute for? Well, for the duration of its execution time, which is 4. So 4 plus 4 is 8. So it'll execute for the duration of 4 time units. So 4 plus 4 is 8. Okay, so you've got P4. So P4 is done. Next, at time interval 8, we have 2 processes remaining, P2 and P5. And out of which one wins? Well, as you've guessed it right, P5 wins because its processing time is shorter. So we'll put P5 over here, and we'll execute it for 4 units. So 8 plus 4 is 12. Okay, so that's P4, that's P5. P5 is also done. The last one remaining is P2, so we'll run that as well. And how long will it run for? Well, 6 time unit 6. So 12 plus 6 is 18. Okay. Now let's calculate the completion time. So when did P1 get completed? Well, P1 got completed at 3, right? So we'll put 3 over here. P2 got completed at 18, right? So we'll put 18 over here. P3 got completed when? 4, at time interval 4. So we'll put 4 over here. That's the completion time of P3. P4, 8. So we'll put 8 over here. P5 at 12. Okay, so that's our completion time. Turnaround time will be equal to completion time minus arrival time. So completion time is this, arrival time is this. So 3 minus 0 is 3. Similarly, the P2 will be 18 minus 2, which is 16. P3, 4 minus 3, which is 1. 8 minus 4, 4. 12 minus 5 is 7. Okay. Similarly, we'll calculate the waiting time. So waiting time is equal to turnaround time minus processing time. So turnaround time is this, processing time is this. So 3 minus 3 is 0, 16 minus 6, 10, then 1 minus 1, 0, 4 minus 4, 0, 7 minus 4, 3. Okay. So that's your waiting time. To calculate the average, so in the examination, it will ask you, please calculate the average turnaround time. So how do we do that? We'll just add all of these in total. So 7 plus 4, 11, 11 plus 1, 12, 12 plus 16, 28, 28 plus 3, 31. So 31 divided by how many? Total number of jobs or processes? 5 processes. So calculate that. 5 6 are 30, 5 2 are 10. So 6.2 is the average turnaround time. Similarly, you can calculate the average waiting time also, which is basically total of all of this, which is 13 divided by 5. So that's 5 2 are 10, and then 5 6 are 30. So 2.6. That's your average waiting time. Okay. All right then, thank you very much. Hello and welcome everyone. In this video, we are going to talk about the round robin method of scheduling algorithm. So what is round robin method? Well, in round robin, CPU runs a process for a given quantum. So when you get a question in the examination, they will give you a quantum, let's say 2. Okay, so the CPU runs a process for a given quantum value, let's say 2 units. And then it puts that process back in the ready queue and runs another process. So as you know, in preemptive scheduling, a process can be interrupted and another process can go ahead and start running. So that's why in round robin, it states that it runs for a given quantum value, let's say 2 units. Then that particular process, let's say process A, goes back in the ready queue, and let's say process B will come and start running. Okay, and the same process is repeated. So how are we going to implement that? Well, we'll create 2 queues, ready queue and running queue. Then first we bring the process in the ready queue and then move it to the running queue and then run it for the given quantum value, let's say 2 units. Next, after a given quantum value, which is 2 units, we bring other process, for instance, P4 and P3, that have arrived at that time in the ready queue. If previously executed process still has time left, we place that back in the ready queue after the arrived processes, let's say P4 and P3. So let me explain to you how this is going to work. So in the examination, you will be given a question. For instance, it'll say that, okay, you have 5 processes, each having the arrival time and processing time. And go ahead and calculate the completion time, average turnaround time, average waiting time, etc. So in order to solve this, we'll create 2 queues. One is ready queue and second is running queue. And then we'll start to solve this. So let's see how we can do that. Okay, so let's say that at the time interval 0, 0, okay, in the running queue as well, as we have 2 queues, ready queue and running queue. So in the ready queue, let's see at time 0 if there is any process that has arrived. So at time 0, we have P1 arrive. So we'll first move that process in the ready queue. Once you move into the ready queue, from here it goes to the running queue. Okay, so we'll go ahead and put the P1 into the running queue. So we'll move that. And how long we are supposed to run it? Let's say that we have been given the quantum value of 2. Okay, which means we are supposed to run each of these processes for 2 units only. Okay, so I would say maximum 2 units. All right, because there could be a scenario where a processing time is only 1. So in that case, we can't run that process for 2 units because the duration is only 1. So maximum 2 is what we want to do. So for P1, we'll run it 2 because its processing time is 3. So it's definitely can be run for 2 units. So we'll run it for 2 units. And once we run it for 2 units, we check at 2 unit of time or at 2 interval of time, are there any processes that have arrived? Yes, we can see that P2 has arrived, right? So if P2 has arrived, then we are going to place that P2 into the ready queue. So P2 goes ahead and moves to the ready queue. All right. And then at that time unit, are there any other processes? No, there isn't. Okay. So since we've already executed P1 for the interval of 2, so what is remaining is 1, correct? Because already executed for 2 units, only 1 is remaining. So once we have brought whatever process had arrived at that point at the interval 2, we're going to put that in the ready queue. And then we also put P1 after that, not before that, because it's not fair to put P1 before P2, because otherwise P1 will continue executing and it doesn't really make sense. We're not really going with the preemptive method then, because if we are allowing all the process, if we are allowing a process to execute fully, then we are not really following preemptive. It will become non-preemptive, because it'll get executed till its processing time. So we don't want that. We want preemptive. That's why we'll execute only for 2 units and put that in the queue. So we'll give chance to P2 or other processes to be executed. So in this case, we put P1 over there. Okay, so this one is done. Now what is next? We have P2, so we bring that in. Okay, so we bring P2, and how long we were supposed to run it? We're supposed to run it for 2 quantum, because that's our quantum unit, which is 2. So that's why we will run it for 2 units. So how much is remaining now? So cancel that. So we have 4 remaining in the P2. Okay. So now at time, this becomes actually 4, not 2, because 2 plus 2 is 4. Okay. So at time interval 4, what do we have? So at time interval 4, we have 1, 2, 3 processes, right? Now P2 is already in the queue, so we can ignore that. What is not there is P3 and P4, because we already have these 2 processes which have arrived at time interval 4. We already have these 2 processes which have already been arrived. So what we'll do is we'll put that in the same order. So make sure you put whatever comes first. Don't put P4 and P3. It'll be P3 and P4. So we'll put P3 and we'll put P4. Okay. So they go ahead and move over here. So P3 moves here, P4 moves here. They go inside of the ready queue. Okay. And then because P2 still have these 4 units remaining, it will be placed after these. So like we place the P1 after the other process that have arrived, similarly, we'll place the P2, whatever's remaining, after these 2 processes. Okay. So we'll put P2 over here. All right. So what next? Next one, we have P1. So we'll bring that into the running queue. We'll put P1. Now what's remaining time? Remaining time is only 1, right? So there's no need to run it for another 2 units because the remaining is only 1. So it doesn't make sense to run it for 2 units. So we'll run it for 1 unit. So it becomes 5. So remember the rule. We should run it for maximum 2 units, right? So in this case, it satisfies the condition. So we ran that. So P1 is done. So check, P1 is done. This becomes 0. So that's fine. And now at time interval 5, what else do we have? So P3 and P4 are already inside of the ready queue. So we can leave that. P2 is also in the ready queue. So we can leave that as well. Now we have the P5. Okay, so P5 is here. So we can put that in the ready queue. And P1 is already finished its execution. So we don't need to worry about it. You know, we can just leave it like that. We don't have to execute it again. So we don't need to put it in the ready queue because it's finished its execution already. There's nothing left here. Okay. So now next P3 comes in. So we'll bring P3 in and run it for 2 units, but we can't run it for 2 units, right? Because only one, its processing time is only 1. So it actually runs it for 1 unit, not 2. So 5 and then this becomes 6. All right. So then P3 is also done. Nothing is remaining, which is great. Now we come to P4. So we bring P4 in. So P4 comes in. Its execution, its burst time is 4. So we can run it for 2 units as per rule. So 6 plus 2 is 8. 6 plus 2 is 8. So we run it for 2 units. We cancel 2. So remaining is 2. Then because there are no other processes which are already present, everything is here in the ready queue. That is why we can simply place P4 at the end, because we still have the remaining units from the processing time left. It is still supposed to execute, so we're placing it here. If we had any other processes that were not put in the ready queue, then we'll place them first and then place P4. But because we don't have any other processes, all the processes are already there in the ready queue, and some of them are already executed, finished their execution. That's why we can directly place the P4 over here. Okay. So now next, we'll bring P2 in. How long we'll run it for? So P2, we'll run it for another 2. So 2 is remaining. So 8 plus 2 is 10. So we'll run that. Remaining, we'll place it here. Okay. Then P5 comes in. So P5, we run it for 2 units, 2 remaining. P5, that becomes 12. And because there is a remaining 2, we'll put P5 over here. Okay. Then P4 comes into the ready queue, running queue. How long will you run it for? 2 units remaining. So now this becomes 0. This becomes 14. Then we'll bring P2 in. How much remaining? 2. So we'll run for 2 units. P2, this becomes 16. And then finally P5 comes in. How much remaining? 2 units. So now it's all done. So that becomes 18. Okay. So all the processes have finished their execution. Nothing remaining. You can see everything is 0 here. And we've actually created a running queue with proper intervals, right? Now we need to calculate the completion time. So when you think P1 completed, so start taking a look from the end, not from the start, because it might have started to execute and then it got interrupted because we brought another process in. That's why do not check it from the left, but check it from the right. So is there P1 here, P1, P1, P1? Okay, here is the P1. So it completed its execution at time interval 5, right? So we put 5 here. Completion time is 5. When did P2 complete? So let's check it from behind. Here it is, P2 at 16. So we put 16 over here. Similarly, what time P3 completed? So P3, let's check it from behind, from the right hand side. That's 6. So we put 6 here. P4, 14. And P5, 18. Okay, so now let's calculate the turnaround time. Turnaround time is CT minus AT, which is completion time minus arrival time. 5 minus 0, 5. 16 minus 2, 14. 6 minus 3, 3. 14 minus 4 is 10. 18 minus 5 is 13. Okay, and then waiting time will be TAT minus PT, which means turnaround time minus processing time. So 5 minus 3. So 5 minus 3 is 2. 14 minus 6 is 8. 3 minus 1, 2. 10 minus 4, 6. 13 minus 4, 9. Okay, so in the examination, it will ask you, please calculate the average turnaround time. So all you have to do is just make a total of this, whatever this total comes in. 5 plus 14 plus 3 plus 10 plus 13, and divide that by number of processes. There are 5 processes. So whatever that value comes in after calculating this, that becomes your average turnaround time. And similarly, you can calculate the average waiting time. So average waiting time becomes 2 plus 8 plus 2 plus 6 plus 9 divided by 5. That becomes your average waiting time. All right. So I hope the round robin scheduling algorithm is clear to you, and I hope you enjoyed it. Thank you very much. Bye-bye. Hello and welcome everyone. In this video, we are going to talk about the shortest remaining time next scheduling algorithm. Now, this is a preemptive algorithm, which means that a process can be interrupted and another process can take its place and start executing. So in this mode, the criteria is that it keeps checking if another process with shorter processing time has arrived. And if another process has arrived, which has a shorter duration of burst time or processing time, then in that case, it preempts the currently executing process. So it moves the currently executing process into the ready queue and brings the new process which is with a shorter processing time, into the running state. It is also known as shortest remaining time first or shortest remaining time. So in the examination, you might be asked this question differently. They might ask you, please solve this problem using the SRTF or SRT scheduling algorithm. So they all are the same, all right? So let's see how we can solve the problem. So in the examination, you might get a question like, there are 5 processes, each have an arrival time and a processing time respectively. And please go ahead and calculate the average turnaround time, average waiting time, etc. And we can do that using the Gantt chart. So let's see how we can do it. Okay, so in the Gantt chart, what we're going to do is we'll start with the time interval of 0 and we'll see which process have arrived at time interval 0. So you can see P1 has arrived. There are no other processes that have arrived at the time 0. So arrival time of P1 is 0. So we put P1 first. So we'll move the P1 from the ready state to the running state, which is will start its execution. And since it has 3 processing time, we are not going to run it for 3 units like we did in other scheduling algorithms. The reason for that is because this is preemptive. Preemptive means that we need to allow other processes also to get a chance of execution. And the rule that we have established is that it'll keep checking after every 1 unit of time in case if there's another process that has arrived, and if it has a shorter processing time than the one that's currently executing, then this will move back to the ready queue and that particular process will come inside of the running state. Okay, so we'll run it for 1 interval and we'll see at interval 1, are there any processes that have arrived? No, because all of these are 2 and above, so there's nothing else. So we'll run P1 for another 1 unit. And now is there anything? So first we'll go ahead and cancel this. So earlier we had 2 remaining. So at this point we had 2 units remaining. And at this point now we have 1 unit remaining. So this actually becomes 2 because 1 plus 1 is 2. Yeah. So at 2 interval, are there any other processes? Let me see. Yeah, P2 has arrived now. Are there any others? No, there aren't. Now, when you need to, so how will you decide whether to bring in P2 or not? Well, it says that you first check if its processing time is the shortest. So what are the processes currently? So currently we have process P1, which is already in the running state, and then we have P2, which is in the ready queue, right? Now, P1 has 1 remaining, 1 unit of time remaining, and P2 has 6 units of time remaining. So definitely we can't bring P2 in because its processing time is higher than the one that's currently being executed. So that is why we can't bring P2 in. So we'll have to let P1 get executed. So we'll put P1 over here. Like we said, we'll run for 1 unit of time each every time, and then we'll keep on checking. So we'll run for another 1 unit of time. So now we run that P1. So now P1 is done. It's finished its execution. Great. At time interval 3, let's find out if there are other processes that have arrived. Yes, P2 had already arrived. P3 has also arrived because they have the arrival time of 2 and 3 respectively, right? So now at this point, whom to bring in out of the 2? Well, the rule says shortest remaining time, right? So which has the shortest remaining time? Shortest remaining time. In fact, these are not even started yet, but you can see that this has got the shorter. This has got the P3 has got the shorter processing time. So that's why we bring P3 in. We run it for 1 unit. So this becomes 0. So P3 is done. It's finished its execution. At unit 4, which are the other processes? So at unit 4, we already have P2, and then we now have P4 as well. Now, which has the shortest remaining time? So P2 has 6 and P4 has 4. So definitely P4 wins. So P4 comes in here inside of the running state, and then we run it for 1 unit. So P4 becomes 3 now. Again, we'll compare at 5. Are there other processes that have arrived? Yes, they have. So at 5, interval 5, we also have P5 that has arrived. So which are the ones that are remaining? P4, P5, and P2. So which has got the shortest? So 6, 3, and 4. So definitely P4. So we can't let anyone else come into the ready queue, running queue. So we have to let P4 continue because its remaining time is less than the others. This has 6, this has 3, this has 4. So 3 wins, which is P4. We put P4 over here, run it for another 1. So that becomes 6. Now P4 becomes 2. Again, we'll have to let it run because of course we can clearly see that it's not gonna happen. So we continue P4, run it for another 1, that becomes 7, and then finally run it for another 1, so that becomes 8. Okay. So 1, 2, 3, 4. So it ran for 4 units of time. Then at 8 we have P2 and P5. So P4 is done. Which has got the shortest remaining time? Well, definitely P5. So we'll let P5 run. So now I can, instead of just making it 9, 10, 11, 12, you know that there's no any other competition. The competition is only between these two. And clearly P5 will win each time because it's got a shorter processing time, the remaining time, right? So I'll let P5 run for 4 units because it makes sense. Doesn't make sense to keep writing 9, 10, 11. I can just say 8 plus 4, which is 12. Okay. So P5 is done. Okay. And the only thing remaining is P2. So bring P2 in, and that's got 6 time units. So 12 plus 6 is 18. And that's sorted. All right. So let's calculate the completion time. So when did P1 get completed? Let's look at from behind. So we have P1 at 3 interval. Okay. Then P2, well, P2 got completed at 18. So 18, right? P3 got completed at 4. So we put 4 over here, and P4 got completed at 8. So we put 8 over here, and P5 got completed at 12. So put 12 over here. Calculate the turnaround time TAT. So that's CT minus AT. So 3 minus 0 is 3. 18 minus 2 is 16. 4 minus 3 is 1. 8 minus 4 is 4. 12 minus 5 is 7. Okay, similarly, we calculate the waiting time, which is TAT minus PT. So turnaround time minus processing time. So 3 minus 3 is 0. 16 minus 6 is 10. 1 minus 1 is 0. 4 minus 4 is 0. 7 minus 4 is 3. Okay, so in the examination, it will ask you to calculate the average turnaround time. You can make a total of this 3 plus 16 plus 1 plus 4 plus 7 and divide that by number of processes. Whatever that value comes in, that becomes your average turnaround time. And similarly, average waiting time will be 0 plus 10 plus 0 plus 0 plus 3 divided by 5. Whatever that value comes in, that becomes your average waiting time. All right. So I hope you enjoyed it. Thank you very much. Bye-bye.